All right, guys, I made a mistake, and I'm sorry. I thought the mistake was on my key, but it actually was in my writing too fast trying to get this video done before I go home for the cold. And this -4 should carry all the way through, in which case the answer key is correct, -1 over 3x minus 12. I apologize for that. So I think we left off with problem 6. Ooh, a good one. So you would like to try to start by saying, do we have a quotient rule? No, we don't. U sub, I'd pick the bottom. That's not going to do anything for me. Also, this thing is top heavy, which means that this is implying and screaming at me, hey, Miss Schwartz, do some division. But the problem is I can't do synthetic division on this one because I've got this binomial that's quadratic. So instead, I have to rely on my knowledge of long division. So 3x cubed plus 2x squared plus 11x minus plus 8. There we go again. I've got a placeholder for everything, and I've got x squared plus 4. So I'm going to start by taking 3x cubed and dividing it by x squared. I'm going to be left with 3x. So 3x times x squared is 3x cubed. 3x times 4 is 12x. And I'm going to subtract. So those cancel. Bring this down, I get 2x squared minus x plus 8. Next thing then, 2x squared divided by x squared is 2. 2 times x squared is 2x squared. 2 times 4 is 8. I'm going to subtract off that whole line. Now I'm left with negative x plus 0. When I go to try to do this, negative x divided by x squared can't happen. So I have negative x left over when I was dividing by x squared plus 4. Okay, so remember, all that did was say this stuff, this whole quotient, was equal to this. So my new integral is now 3x plus 2 plus negative x over x squared plus 4, because I haven't done any calculus yet. Okay, well this is good because now I've got addition going on, so I can do each one of these pieces individually. So the antiderivative of 3x is going to be 3x squared over 2. The antiderivative of 2 is just going to be 2x. And now I've got this antiderivative of negative x over x squared plus 4 dx. And I don't know what that is off the top of my head. But if I look at this, I notice that this thing is, again, a quotient. So I'm supposed to divide. This time, though, a u sub will work for me. And I want to pick u to be the denominator. So then du is equal to 2x dx, and I've got to adjust by this 2, and there was a negative here. So I'm going to have a negative 1/2 the integral. Now all of this gets replaced, and I have 1 over u du, and I do have a rule for that. So 3x squared over 2 plus 2x minus 1/2 the natural log of x squared plus 4 with absolute value bars, all plus c. Now, could you check your answer by taking the derivative? Sure. Would it look kind of different than what we started with? Yes. But would they be mathematically equivalent? Also, yes. All right, onward. We did number 7. Number 8. All right, 3x squared minus x plus 4. Do I have a division rule for integrals? Hopefully you're screaming, no, you still don't. And you would be correct. So the next thing I want to ask myself then, can I do a u sub? Well, if I pick u to be the denominator like I'm quote-unquote supposed to, u is just equal to x, and then that's just me changing out variables and deciding I don't like x, I'm going to use u. So our last thing that we want to try is, what does this bar tell you? It tells you to divide. Well, this is a monomial on the bottom, which means my division is actually super quick. So this will become the integral. 3x squared over x is just 3x, minus x over x is 1, plus 4 over x dx. I can integrate each piece. This will become 3x squared over 2. This will become minus x, and now I've got plus the integral of 4 over x dx. That one's not so great with me. So I can take out the 4, and then recognize that this is actually just the natural log rule. And so I still have this minus x and the 3x squared over 2. final answer. All right, cosine over 1 minus sine x. Well, I've got a division problem. I don't have a quotient rule. Still, it's very sad. So I want to try a u sub. And generally speaking, I want to try the u that's on the bottom. Also, when we pick u's, we want to pick a u where we see its derivative. So u being on the bottom would be u equals 1 minus sine of x, which means that du is just equal to negative cosine of x dx. So when I go through and I replace everything, I have to adjust by the negative sign, right, for the dx. So this will be negative du, and this will now be 1 over u. Oh, that's not so bad. Negative natural log of the absolute value of u plus c, which is really negative natural log 1 minus sine x plus c. There are no trig identities you can use here to help simplify because you don't have 1 minus sine squared. If it was 1 minus sine squared, you can work with Pythagoras a little bit, but unfortunately, you don't have that. All right, last one, x times cotangent of x squared. Well, in thinking about this, I've got a product going on, so I know I want to try a u sub, and I want to pick the u to be whatever inside of the function. So u is going to be equal to x squared, which means that du is equal to 2x dx. I'm going to adjust by a 1/2. If you're still not clear about why I'm adjusting in that way, you might want to go back to the u sub video from earlier in January and watch that. And now from here, I can use my quote-unquote memorized fact, 1 over 2. The antiderivative of cotangent is the natural log of the sine of u plus c. Going back and replacing my u value. This would be my final answer. You also can do a little temporary sidestep if you're not into memorizing and say this would be the same thing as cosine of u over the sine of u du. And you can do the full, w substitution thing, etc., etc. Or you could just tell yourself, I would have picked this to be my substitution. So that's the part that's going to be ending up inside of that natural log for the cotangent. Okay? This is one of those times where I do not memorize the integral of secant, the integral of cosecant, the integral of tangent, or the integral of cotangent. In my head, I just try to think about what patterns do I have and what would I have picked for my u substitution. All right, that's it. Hopefully that helps you in your review for Friday. Remember to email me or Mr. Lakin if you have any questions on anything. If you are trying to memorize these things, think about what's inside the absolute value after you get the natural log and see if you can find some patterns that go in there. All right, happy studying, stay warm, and I hope to see you soon.